Good day, everyone, and thanks for joining us. I'm John Mallory, a Storage Business Development Manager for AWS, and today I'd like to talk about S3 security best practices. So let's begin with the foundation of security best practices, and this is the concept of least privilege. Essentially, what you want to do here is start with a minimum set of permissions and only grant additional permissions as necessary and as needed. This is foundational because it's much easier to grant rather than to give people general permissions, try to figure out who has what permission, and then take away if they've exceeded their authority. Before you do this, though, you really need to start off and do some research and do your homework and define up front the right set of permissions. And these boil down to what actions a particular service supports, what is required for that specific task, and what permissions are required in order to perform these actions, and who has access to perform these actions. So with that said, one of the foundational tools we use for all AWS security is IAM. And essentially, what you're going to do with IAM is create and manage AWS users, groups, and permissions to control access to AWS resources. It's a powerful tool because it controls across an entire set of AWS resources, users, and groups in a coordinated fashion. And furthermore, it integrates with Active Directory using SAML for identity federation, as well as AWS Directory Services. And essentially, you can create roles and assume roles to control what operations can be performed by an entity or an AWS service. And as we'll wrap up talking about, this really becomes important in data lake style environments. So let's dig into S3 IAM policies. Essentially, this dictates what can a particular user, and as I said, this user can be a person or it can be a task or a function, what can they do in AWS with S3? And so essentially what this does is it directly grants access to S3 service actions. And essentially this is managed within the IAM environment and controlled by IAM administrators. So you can start to get separation of control and other functions. And it's attached to IAM users or roles, and this can include things like EC2 instant profiles, if you're running applications on EC2, or third-party managed services like EMR. And optionally, and fundamentally important for a lot of multi-tenant customers, is you can start to specify buckets and prefixes. So if you look at this code segment on the right-hand side, essentially you can see that you can get very granular in what actions are allowed. For example, you can grant actions to put objects, put object ACLs, get objects, delete objects. So essentially you're explicitly granting permissions to take activities, and then you specify the resources, and you can specify buckets and prefixes to start to separate data resources and map those granularly to different users, different groups, different tools. You can also use bucket policies, and essentially this defines who can access this S3 bucket. So it really further defines what users can do with buckets. It's attached to the bucket itself. So unlike IAM, where this is attached to specific roles, this is really controlled and belongs to the bucket owner. And so this is really a good way to grant access without using IAM roles, or to get more policy depth if you want to conserve IAM role policies. And essentially this keeps access control policies in the S3 environment. So if you've got an environment where you're using S3 for data sharing, or really as a foundation for web-based apps where it's predominantly access to S3 is going to be the major actions performed, bucket policies can be a valuable tool to use. And you can essentially start to also get very granular and define your resources down to individual prefixes. We also have, beyond bucket policies, S3 access control list. And while this is a very powerful tool, we should really only use this when absolutely necessary. Because essentially this allows you to manage permissions down to individual object level, but you can't explicitly deny, and they grant access, and so it's easy to make mistakes. So really, my recommendation is, in general, use IAM policies and bucket policies as much as possible, and only use ACLs when absolutely necessary. Because users can do things either intentionally or by mistake, such as using stars or allowing predefined groups like everyone, which, as we'll talk about later on, can be security vulnerabilities and inadvertently expose data, to the public. And ultimately, though, when you look at authorization, it's always a union of the combination of IAM policies, bucket policies, and ACLs. So essentially, if you look at this decision tree, we'll start at deny, evaluate all applicable bucket policies, and then go through a logic tree to figure out, what the final decision is. So if there's an explicit deny, which back to least privilege is, always a good place to begin your security, that will be the final decision. But if there isn't explicit deny, then it will go and it'll evaluate for allows and, kind of go through the chain. So this is powerful, but at the same time, it can be complex to debug if you do find yourself inadvertently exposing buckets or objects within a bucket. So, this is why ACLs, in general should be avoided unless you have an explicit need for them. Presigned URLs is another way to grant access to both put and get objects in an S3 bucket. So essentially the way this works is, a user, provided they have, the proper security credentials, can generate a URL to an object in a bucket by specifying, the HTTP method and an expiration date and time, and that URL will remain valid until that expiration time. And then, the person, it essentially uses the permissions of the user who generates the URL, and they can give that URL to the intended audience who wants to be able to put or get objects in S3. It's a powerful tool. We have customers using this as an implicit part of their security, but it's a double-edged sword because it's essentially bypassing user authorization. So while it makes it easy to grant and share access, you really have to make sure that the user who's creating this URL is trusted, because you can think of a scenario where a rogue actor could essentially, assuming they have the permissions, give pre-signed URLs to external parties who may have malicious intent, and they can then use those URLs. So powerful tool, but really needs to be carefully thought out and ultimately, used only by trusted and appropriately credentialed users. So this is all about granting access, but the second level of protection of your data is really encryption. And what is encryption about? And it is a fundamental thing that should be used in the cloud at all times. What people say it's about is compliance. It's a best practice in security. I want to protect myself from other cloud providers, other customers. And I want to protect myself from my cloud providers so they can't snoop my data. But what people really mean and what this is you want to minimize unauthorized physical access to data. Number one, that's where security policies come in. And secondly, you want to minimize unauthorized logical access to data, meaning if somehow inappropriate security policies are applied, an unintended user gets access to an object, you've now got this other level of protection in that if they don't have access to encryption keys, that object is meaningless. So it's about confidentiality, integrity, availability, CIA. And so let's have a little review of encryption and how it works. And essentially, it starts off with you've got your data and you're going to generate encryption data keys. And those can be done in either hardware or soft key. And we prefer to use symmetric keys because we typically don't know what size the objects are up front, and we want it to be fast. And essentially, the key takes open data and uses encryption algorithms like AES, and essentially the encrypted ciphertext is what's stored on S3. And ultimately it lands on S3 and it's stored encrypted. And now, so essentially you have the data key, but the challenge you have here is, you want to separate the data encryption key and the data itself and make sure that, there isn't unintended access to the data key because essentially you're going to want to have to unwrap that. So the concept we use here is a customer master key, which essentially it's an encryption key for the data encryption key. And this is fundamental to kind of segregating this capability and applying that second level of separation where, you have the customer master key that you, the customer, owns, and then it controls all of the data keys. This also gives scalability to key management. And essentially then you have a hierarchy of keys. So what are the different types of encryption you can use in AWS with S3? The first is essentially server-side encryption. And as we talked about, this uses a two-tiered key hierarchy using envelope encryption, where a unique data key encrypts the customer data and the individual objects, and the customer master key encrypts the data keys. And so as we talked about, this separation really limits the risk of a compromised data key, provides better performance for encrypting large amounts of data, and instead of managing potentially billions of data keys if you have billions of objects, you're only managing a small number of master keys. And then by centralizing the management of that master key, you're really giving a single point of access, and you're being able to audit all that key activity. So really an important concept. And the other thing to remember about encryption is it's great for protecting data, but the flip side is if you lose your keys, you lose your data. So that's why it's really important to try to integrate the customer master key management into a key management service, which we have AWS KMS, Key Management Service, which is really a highly recommended practice that we typically use. So what types of encryption does S3 support? Essentially, by using HTTPS and TLS, we have industry standard encryption for data in motion. So that's covered. When the data is in flight, it's encrypted. But then we also use encryption at rest. And there are a few different ways to do this. Essentially, we can use client-side encryption, which is where the client encrypts their data before they ever upload it. Security-conscious customers often want to gravitate towards client-side encryption because they feel like they control the keys, the data is always going to be encrypted throughout AWS, and that's fine, but it has a lot of downsides in that, they are now responsible for managing the keys, and as we'd said, if they lose those keys, screw things up there, they lose access to their data, and there's nothing we can do about it. But if you think of our direction of more and more services wanting to be able to act upon data in S3, things like Athena, EMR, Redshift Spectrum, S3 Select, so on and so forth, all these great services that we're bringing to integrate with the data itself to extract more value out of the data, client-side encryption most generally breaks this because we don't have the keys to unencrypt that data, and so we can't use it. It just looks like opaque data to us. So it really limits a lot of the value that we bring to what people can do with their data. So really, we recommend using server-side encryption. And there are a couple different ways to do this. There's server-side encryption S3, where Amazon S3 manages the data and the master encryption keys automatically. And this is fine, particularly if it's a data-centric application. You've got a limited number of buckets, a constrained environment. You've got SSEC, where you, the client, manage the encryption key. And back to our previous discussion about client-side encryption, generally not recommended. And really the gold standard that we want to gravitate towards is SSE KMS, where Amazon S3 manages the data key and you manage the master key in the AWS Key Management Service. And this becomes important, back to that statement about wanting to have a lot of services have access to the data and be able to perform analytics on it, perform processing of that data. They can all refer back to KMS, and security and key management and encryption now get coordinated across the entire application stack. So takeaway is use KMS where possible. So now I'd like to talk about some relatively new security features that we've introduced for S3 over the past 6 to 8 months, and dive a little bit into those. The fundamental concept about security is it's obviously a shared responsibility model. We provide the foundational security tools, including all of the ones we've talked about access permissioning and encryption, and the user's responsible for using those tools responsibly. It's a great model. We're not deviating from it, but ultimately, either through inexperience, through honest mistakes, or potentially through bad actors within an organization, the shared responsibility model can break down on the customer side. So what we're trying to do over time is get more and more sophisticated and provide more and more automation and make it easier to use the tools that we have to help protect customers from themselves and from making these mistakes or from bad actors within their organization. So a lot of the new security features we're driving S3 are really dictated with that premise. So what have we released recently? We've essentially done S3 inventory, where you can both get encryption status in a single report, and you can also encrypt this inventory report, back to that concept about encryption providing that second level of access against users unintentionally accessing something they shouldn't. We've added CRR support for KMS encrypted object and ownership override, and also default encryption and being able to check bucket permissions in the S3 console. And I'd say default encryption is a really powerful tool, as we'll learn more about, so I give that one a wow. So what is S3 inventory? Essentially, if you're not familiar with it, you can sign up for an inventory report, and either daily or weekly, you'll get this inventory report in your bucket, and it will contain a list of all of your objects and information about those objects. So rather than having to do lists to see what you've got, you can now just get an inventory report that gives you a consolidated review. And a couple of things we've added to this inventory report specific to security is you can now get object level encryption status. So you can, if you have encryption policies, you can go and review those very quickly. You can encrypt the inventory report itself using either server-side encryption or KMS. It's now output in an ORC format, which really ties into being able to query it with Athena. So you can now have console-level serverless querying of these inventory reports, so you can really get granular in digging into, down to the object level and writing queries to look for things like objects that aren't encrypted very quickly, very easily. So let's talk about encrypting inventory reports. I come back once again to the concept of using KMS whenever possible. And essentially, you can encrypt your inventory report using KMS where you have to grant S3 permission to encrypt using your AWS KMS key. And so you do this through the management console, where essentially using the account that owns the customer master key for KMS, you can open the identity and access management console, choose encryption keys, choose the region, since KMS keys are region specific, and then choose the alias of the customer master key you want to encrypt the inventory report with. And then finally, in the key policy section of the page, choose the switch to policy key view. And essentially, you'll get this text on the right. You'll copy this key policy into the key policy editor, save changes, and now you're all set. So let's talk about cross-region replication with support for KMS. We've had cross-region replication for quite a while, and what this gives you is the ability to take objects in one region in an S3 bucket and send those to another region. And obviously, you've got objects encrypted at the source, but as I'd mentioned earlier, KMS keys are regional. And so until we made these changes, you couldn't use KMS support for essentially sending encrypted objects over the wire, which a lot of customers who are in financial services, industries where objects had PII data, they had concerns about that. So essentially, we close that vulnerability with this, and now what you can do is you encrypt your data at the source using that region's KMS key. When you go and set up CRR policies and they replicate the data, you've got the TLS connection between the two regions, which encrypts the object in flight. But then you've also got the coordination with the destination's KMS key, so that now objects are coordinated between source region, destination region, and the KMS management of those keys across the regions is also coordinated. So that in a nutshell is CRR with support for KMS. Another key factor is being able to do ownership override of cross-region replication. And what drove this was to protect against what we call rogue actors, where essentially, and we've had this happen with major customers where they have a disgruntled employee, a bad actor within their organization, essentially can go and, if they have appropriate permissions, start to delete or corrupt or overwrite data in one location. So what CRR with ownership override does is you can use CRR, replicate the data to another region, and then select a different owner for the destination bucket and give them a completely different permissioning structure. So even if the rogue actor does something in that source bucket that impacts your objects in that bucket, they don't have access, if you've done your permissions correctly, to the data in that second region's bucket. And so now you're protected against any actions that they would do. And so really, this essentially gives you business continuity where you can use object to ownership override to separate the access control between source objects and replicated objects so that the source object owners can't read, update, or delete replicated object. So, this is a great protection against real-world security events that we've seen. And essentially how it works is you're going to add an account and access control elements as the child element of the destination element, add the appropriate permissions to the IAM role to allow S3 to change replica ownership, and then add permissions for the object owner override to bucket owner that will allow the AWS account to essentially the owner that owns the source, the account that owns the source bucket, to change replica ownership on the destination bucket. And essentially, KMS cross-region support, just to close off on that, as we've mentioned, and summarize the combination of these two. KMS keys are region-specific. You can specify different KMS master keys by prefix. The objects remain encrypted throughout the replication process, and you provide the AWS KMS management key for the destination bucket region that you want S3 to use. And you need to go in and grant additional permissions to the IAM role so that S3 can access objects using KMS keys. One thing to be aware of when you're using KMS, I've said over and over it's a best practice, but there's one thing you need to be aware of is that KMS has an API rate limit, and essentially if you're using CRR with KMS, every request is essentially doubled. So one request essentially results in a doubling of KMS API request. And so really what you can do to address this is go back and request to essentially have a KMS API rate increase via support. And there's no additional cost for this. It's just something you need to go and request. So use KMS, but be aware of potential throttling and look for it. But upfront before you typically use it, we'd recommend going and opening a support case and increasing the limit by default. So let's talk about encryption by default for S3 buckets. Another new feature we introduced late last year. And essentially what this does is it provides S3 encryption at rest support for applications that don't otherwise support encrypting data in S3. So whether the application can't set encryption when it does puts, or a user doesn't know how or inadvertently forgets to, this will essentially encrypt by default. So it's a one-time bucket level setup. It automatically encrypts all new objects, and the emphasis is on new here. It doesn't go back and encrypt existing objects in a bucket, makes it simpler to get compliance, and once again, this supports both server-side encryption S3 and server-side encryption KMS. And so essentially, what does this look like? You can go in your console, your S3 console, and set it up very quickly, very simply by selecting default encryption. So you can either, as I said, it doesn't affect existing objects in your bucket. So you can either use AES 256 server-side encryption, or you can use KMS encryption. And, essentially, that's all it takes to set this up. And so how does this really work? Essentially, it ensures that all put requests include encryption information automatically. It ensures that you will automatically encrypt irrespective of the put request having encryption information or not. Because in the old world, you essentially, be it you, the user, or the application that's putting data, had to ensure that all put request included encryption information and set up a bucket policy to explicitly reject unencrypted put request if you wanted to ensure that objects were encrypted. So now, you can automate this. And so really we're targeting customers that have requirements like PCI or SOC 2 or HIPAA for PII data where they absolutely need encryption. Finally, a key part of security is really being able to inspect and audit. It's not enough to set up the right access controls, ensure you have encryption. If you're in a regulated industry or you just have a robust security policy, you've got to go back and inspect, prove, and flag errors as quickly as possible when they happen. So we've got some tools to help you here as well. essentially what we have here is Trusted Advisor has been around for a while. We now have added a bucket access control view to S3 console, so you can quickly and easily see when you have buckets that may have publicly exposed data, which has been a sensitive point for customers who may not realize that they've inadvertently set things like ACLs to grant public access. And then finally, you've got object encryption status in your S3 inventory report. And so essentially with Trusted Advisor, it now has 3 Amazon S3 related checks, including being able to check bucket permissions. So essentially it will check bucket permissions and let you know, give you alerts essentially if you have bucket ACLs that will allow everyone to list, bucket ACLs that, or a bucket policy that will provide any kind of open access, or if you have ACLs that allow upload or delete access for everyone or any authenticated AWS user, and provide recommended actions. Another key check, as I'd mentioned, is bucket permissioning checks in the S3 console. Essentially what this does is it uses a service to go and examine bucket ACLs, bucket policies, since I'd mentioned this as kind of combinatorial math, to take the union of all of these, this has the intelligence to look at all those permutations and combinations and essentially examine the union of bucket ACLs, bucket policies, to determine if these buckets are publicly accessible. So it checks for buckets in S3 that have open access permissions, such as bucket permissions that give grant access or list access to everyone, which can result in higher than expected usage charges since we charge for list, particularly if unintended users do it at high frequency. It also checks for bucket permissions that grant upload and delete access to everyone, which can be a huge security vulnerability because now, if you inadvertently use a star statement, you could allow virtually anyone to add, modify, or remove objects in a bucket. So the key terminology to be aware of when using bucket permissioning checks is public, means that any authenticated AWS user plus everyone, which is someone that could be making anonymous calls, can have access to either list, upload, or delete. And access itself means read, write, or read or write access control policies. What bucket permissions don't check for today is object ACLs themselves. So it doesn't check the individual objects, it just checks the overall bucket level policies. And so what you get with this, if you go into your console, essentially is this new access column, which you can quickly and easily see buckets that are not public and buckets that are public. And then across the top, you get a flag of how many of your total number of buckets have public access vulnerabilities. And you can then start to drill down. And so essentially you can start to use the search function to look for buckets with any public access, read, write, buckets with public read access, buckets with public write access. And from there, you can then drill down, and using these filters, we mentioned earlier we had 3 buckets that had public access. You can then see read access, write access, and what the source that's providing these public access points are, whether it's ACLs or whether it's the bucket policies themselves. And then furthermore, from there, you can drill down into those individual buckets and start to look at accounts that have access to those buckets, and then look at their policies and, do they have list objects, write objects, read bucket ACLs, write bucket ACLs, and get down to that level of granularity. So through the console, you can quickly get an overall picture, and then on buckets that have public access, drill down and get granular and see who has these public access. Because Ultimately, if you're in a place where you're using S3 to share data, you may have some data sets you want public access to, some accounts, and others that absolutely not. So a good way to peel that back very quickly. And another way you can do this is using AWS Config, where essentially you have managed rules to identify insecure bucket configurations as well. Things such as public rights prohibited, public reads prohibited, request only. And you can verify and use managed rules to verify that the right security features are enabled, including logging and versioning. Quickly visualize these changes in your S3 bucket configurations and get alerted of changes if somebody goes in and changes policies via SNS. So also rolled now into AWS Config, and another powerful tool for monitoring. And then finally, CloudTrail is a really important to audit access. I mean, you want to use CloudTrail, which essentially looks at every S3 API event, logs it. So essentially all bucket level actions will be sent to CloudTrail, and then you can drill down and start to get more granular, turn it on for per bucket, per prefix, or per object basis, or for all buckets in an account. And that gets sent to Amazon CloudWatch logs, and you can start to customize this and get very detailed information such as IP address, user agent, access key used, and request ID. So if your security organization requires detailed audit, this is the way you achieve this. And you can imagine that that can generate a huge amount of data. There are multiple ways to go through those logs, analyze those logs, but Athena makes it quick and easy to do ad hoc queries of these logs, either S3 access logs themselves or CloudTrail logs for S3 specific actions. And you have, we have predefined DDL statements for Athena to make it quick and easy to know how this data is structured and go in and write queries to quickly do this. And finally, in the spirit of innovation, last year we introduced a new service called Amazon Macy, because I mentioned that a lot of these reports that we do within S3 don't go down to the individual object level. If you want to go to that level, that's where Macy comes in. Essentially, it uses machine learning to automatically discover, classify, and protect sensitive data in AWS. So what it does is it actually scans the data in S3, and obviously this has cost implications, so you want to be aware of that before you use this. But once you've sorted through that, essentially you can go through and look at individual objects, essentially look at the contents to identify PII, PHI data, and start to, excuse me, start to audit, who has access to what, and where is sensitive data, and what are the security policies for sensitive data, and who might have changed those over time. So a very powerful tool to really get down to the individual object level and look inside of objects for data that is PII. So why is this important at the end of the day? I mean, if we lived in a world where you had a small number of users, unified access to the bucket and data in S3, it'd be really easy. But if you think about the real world, particularly as people start to think about collapsing multiple silos of data into a single data platform and bringing the tools to it, security becomes a lot more complicated. Because essentially what you really want is multiple teams, multiple users, using multiple tools and sharing access to data in S3 buckets. Classic data lake problem and security challenge. You want to grant fine-grained access to the data and resource ownerships where teams can share S3 buckets and data within there, and really set up a shared service architecture, but then get very granular in who can see what, who can do what, irrespective of the tools they're using. So what this starts to look like is this type of architecture where different teams are going to want to be able to do different things with different data, but essentially you want to tie ownership of all this together. So how do you do this? It really gets down to using all the tools that we've talked about and building upon them. Essentially, identity and access management, or IAM, is the default for this because, as I mentioned at the outset, this essentially gives coordinated access across users and applications throughout the AWS environment. So it really ties security all together. We have Cognito, which is often used in data lake environments, can start to do different role management and almost act as a gateway. As we just talked about, CloudWatch and CloudTrail are essential for auditing who's doing what and looking for inadvertent, unintentional, or malicious changes. Encryption is key because even if access is inadvertently granted, if they don't have access to the master key, that data is meaningless. And so to make this easy to manage at scale and coordinate it across all services, use KMS. And ultimately, if you're starting to use EMR extensively, you can also use the Apache projects to manage security, such as Ranger for EMR. If you're lifting and shifting from on-prem environments like Hadoop, you can use same best practices in AWS. But ultimately, security is really about tying all these tools together, using the tools we give you, but then being intentional about what you want to do, really being mindful of mapping your security environment and controlling it on your side and coordinating it all with the tools we provide. So thanks again for joining. Hopefully this has been useful, and thank you.